Alright, so we're in college algebra, UW Whitewater, talking about concepts from 3.2, section 3.2, talking about changing the time frame of an exponential function. So in general, if I've got this situation, if I've got a pen, if I've got a situation where we've got a situation with bacteria population, certain culture grows exponentially. So we've got growth exponential, we've got exponential growth, we've got f of x equals c times a to the x power. C is our starting amount, a is our growth factor. Growth factor a can be modified in this type of situation. So if we've got something like this, let's say I've got a 20-minute growth factor. Remember, the growth factor is what multiplies one value to get to the next y value, to get to the next f of x value. If the 20-minute growth factor is small a, then the 1 hour growth factor is. How do we figure that out? Well, if I'm talking about bacteria and time, I could say time. I could set up a XY table, time and bacteria. If I've got time and bacteria, I start with 0, and I know that my 20-minute growth factor is a. So 20 minutes goes here, and I know that my bacteria would multiply by a to get from time 0 to time 20. And that's just kind of the definition of what growth factor is. You're taking the bacteria here at time 0, multiply by a as a growth factor to get to 20, the 20-minute, or the amount of bacteria at 20 minutes. So that would be our a, and if we wanted to say a is, or x is in terms of 20-minute segments, every 20 minutes this would be the c value, or every c value, every amount of bacteria would be multiplied by a. We could leave a as whatever we were given here as a, and we'd be done. And we'd say x is the number of 20-minute time periods. But we need to know the 1 hour growth factor. So if I need to know the 1 hour growth factor, I'm going to put 40 down here, and I'm going to put 60 down here as well, because what I need to do is I need to find the 1 hour growth factor. I need to know what I'm multiplying by from 0 to get me to an amount at 60. So if I look at this, I'm going to take my a, my factor a, my growth factor a, and multiply my amount at time 0, multiply by a to get to my amount at time 20. And from 20 to 40, I would again multiply by a. From 40 to 60 minutes, I would multiply by a. And essentially that would be all three of these put together would give me a cubed. And that would equal my growth factor. I'm going to call it big A, just for the idea that I'm multiplying from 0 to get me 60. So that would give me a growth factor of big A. So a cubed equals a, or every 20-minute growth factor, the 20-minute growth factor cubed. 0 to 20 gives me a, got to multiply by a. 20 to 40, got to multiply by a. 40 to 60, got to multiply by a, the small a's. And that gives me the a cubed, and that's equal to the big A. The big A is my 1 hour growth factor. The small a is my 20-minute growth factor. So the relation is a cubed equals a. The small growth factor, or the 20-minute growth factor cubed, gives me my 1 hour growth factor. So now if I put in real numbers here, if I said, well, for example, if I set a number here, if a were 8, in other words, if I took my bacteria count at 0, took my bacteria count at 20, and this 8 was, well, multiplying by 8, you could say that it would be 1 and 8, for example. If I put those numbers in there and I found out my growth factor A was 8 for 20 minutes, then I would cube that, and I would say, well, my 20-minute growth factor is 8. Cubed is what my big growth factor A. So 8 cubed is 8 times 8 times 8, 64 times 8. Pretty big number. I don't know what that number is, but that would be 8 cubed, and we'd have to put a number right over here. So 8 cubed would go right here as my 1 hour growth factor, and that's how we'd figure a 1 hour growth factor.